The next one is HEMT, Gallium Arsenide HEMT. HEMT is high electron mobility transistor. So already Gallium Arsenide is having a very high electron mobility. We are going to enhance that property and make it even more faster. So this gallium arsenide based HEMT will have a considerable increase in it is more good in performance compared to MESFET, and the gate is made very thin. So when the gate is made very thin, the depletion region is very small. Electrons can move faster. So you see the operate when you make the gate. Previously the gate was 0.5 and operation was still 30. When I make the gate even more lesser, the operation goes to 100 gigahertz. So the device is going to work till 100 gigahertz without any problem. That is a very good advantage for me. Okay, high frequency and circuits கிடையாது. But when gallium arsenide HEMT is going to give me such a wonderful feature, I'll be able to use gallium arsenide HEMT in the high frequency regions. However, these high performance devices are less suited to high volume manufacture than MESFET. But what's the drawback? When the gate length is very small, you cannot manufacture them as a bulk. The production will be a very tedious task because you have to make such a gate of a very small dimension using technology. Technology is available, but it is a very time consuming process. You see so many technologies like MBE, molecular beam epitaxy, MOCVD, metal organic chemical vapor deposition. So when you do all these technology, when you apply all these techniques in fabrication, gate length of 0.1 mm will come. The device will be fabricated. But what is the drawback? All these processes will take more amount of time when you compare the time taken for MESFET. When you compare MESFET and HEMT, HEMT is superior in performance, but fabrication wise, HEMT is very tough. Or I can say HEMT takes a longer amount of time. So for very good noise figure, one more gate is required. So which must be produced in a precise way. So இங்க வந்து HEMTல the technology will take a major role. The technology should be perfect. The technology is not perfect and quality, it is not having any quality, then how much ever care you take in fabricating all these HEMT, it is not going to give you any value. Because HEMT, when you're going to make the electrons move faster, the depletion region has to be thin. That is done by having a reduced gate length. So when you reduce the gate length, the performance is very good. But for the reduced gate length, the fabrication is going to be tougher and it is going to take a longer and longer duration of